So with that, let's start with Chandra. And here you go. And please introduce yourself as well. Sure. Thank you.
Thanks, Karina. So I'm Chandra Sekar. I'm a data and AI specialist with the Microsoft Federal. What that means is I help federal customers develop, design, and deploy solutions that are pertaining to data analytics and AI in our Azure cloud. So today, rather than, I think everyone knows what is big data, what is Hadoop. Instead of trying to stick with the definitions, why should you embrace that technology is what we are going to talk about. The number one reason, especially with Mark Resanovich showing up for next month and talking about digital transformation, I want to set the ground. What is digital transformation? If you're thinking about for the past 10 years, 20 years, you took a paper form and called it an e-government by putting a web form in a website, that is just e-government. That's not digital transformation. What we are talking in this digital transformation era where data analytics and AI could actually accelerate you is completely taking your business process, whether it's being a business or a government agency, and looking it upside down where you can automate things and where you can take intelligent action and how AI can actually help human decision-making process. So a blockchain is a typical example where it can eliminate the middleman and change your process completely. And if you don't change with the technology, you are becoming obsolete. So that's why we need to embrace big data technologies, look at cloud, and incorporate into your digital transformation roadmap. But why now? It's because we are at a culmination of these three technologies. Artificial intelligence, big data, and IoT. To me, IoT is nothing but fast data. If you look at the definition of big data, the volume velocity, that's where the IoT data comes in, and cloud. So if you look at it, the artificial intelligence, machine learning algorithms, neural nets, I don't know how long you went to grad school or undergrad school, those were there in 1980s. But they were never taken to this level of actual commercial implementation because the machines were not powerful. You need a supercomputer to run those modeling. But with the advent of cloud and the big data technologies, you can actually bring it to a commercial enterprise environment and excel at it. So that's why I think it is now time to embrace these three technologies and develop modern solutions. So little history on what Microsoft is actually doing with it is actually solving the challenges that's behind these big data analytics. Resources, having skilled resources and integrating with legacy technologies. It's been hard. If you ever installed a Hadoop cluster and try to integrate with your ERP system, have the data flow back and forth, you know the difficulties. It's pretty hard. Microsoft has gone through these pains. So we have exabytes of data, starting with Hotmail back then, Bing searches, the number of Windows diagnostic logs that come into our engineering department. We have dealt with the exabytes of data, and we know how to solve the big data problems. So what Microsoft is doing in this cloud-first, AI-first world is actually taking those technologies and bringing to the customers, not just like yesterday's Microsoft, where we would develop a product and push it to the customers. This is a completely new world of Microsoft where we take those technologies and we take the experience and come and meet where the customers are. Where the customers are, they are with the open source technologies, they are with Hadoop, and that's where the customers are comfortable with. So we actually merged both, and we are bringing intelligence our Microsoft's vision is to bring intelligence where the data is. And if you look at it, even the advent of, I don't know how many of you were programming when mainframe was around, it still is around in some agencies. Dealing with ISAM files, your application was very hard to write. You have to write all the database administration, indexing, all the code in your application. And currently what Microsoft thinks in the machine learning AI world, that's where the application is right now. You are building machine learning models and building algorithms and trying to do the learning process, retraining process of an AI into your application instead of solving just the business rules. So what Microsoft is doing is pushing that modeling and having the machine learning happen in the database itself. So you would see that first in our product, SQL Server. SQL Server 2016 and 2017 has this capability. It has inbuilt database analytics. What that means is you can run R, Python in SQL Server. So you would build a model using R or Python, incorporate it into your SQL Server where your structured data lives, and your application just calls a store procedure. It does not know there is a R or Python code running behind. So that's our vision for the customers who are already running SQL Server. And how many of you know there is an Ignite conference going on this week? And my slides are changing. They are changing them left and right. So we used to call it the Microsoft R server, and they took that product and they incorporated Python. Why leave the Python community out, right? So the R server handles both R and Python. So you can build machine learning algorithms in that and deploy to the R server. So we call that a Microsoft ML server. So that can be run in our cloud, or it can be run on-premise. It can be run on Teradata. That's the new Microsoft. So you can deploy that ML server anywhere you like. And in today's talk, I'm going to focus mostly on the cloud analytics piece. What can you do in the cloud analytics? Just a brief overview. This is pretty much the reference architecture and how the Microsoft products in the Azure GovCloud fits in. You bring in data. The data could be coming from your applications, different data source. It could be just Flash files, Excel files coming in, or it could be any of the IoT sensor devices. You bring in the data, you do data management. We have a data pipeline building tool called Data Factory, or if you want to catalog it, data catalog, or if it's IoT, one of those fast data coming from your sensor, this is our fire hose to ingest data into it. So that's called event hubs. So you can bring in almost like 1 million to 2 million messages per second. That's how fast you can ingest data into it. So once you bring in the data, how do you store them? So we have a data lake store, which is pretty much any unstructured data, any format of data. There is no limitation. You can store petabytes of data into it. You can literally dump data into the lake. Or if you are more familiar with the structured data, you go into the SQL data warehouse and build your cubes and dimensions and facts, those. And Cosmos DB is just our underlying distributed file system to support any NoSQL databases out there. So Cosmos DB will be your underlying platform for a NoSQL application, and the API can be any of the document-based DB or MongoDB, or for the graph databases, it's Gremlin API. So what I'm trying to picture here is there are many options, and the way you select which tools that's near and dear to your heart mostly resides from the resources you have and the problem you're trying to solve. So when you step into the machine learning or data analytics world, you have tons of choices. Going from the bottom out there is the Azure analysis services that goes hand in hand with your data warehousing tool. Stream analytics is real-time analytics. You can write SQL on a streaming data that's coming in. Or you can install a Hadoop or a Spark cluster and do data analytics using Spark ML or in-memory Spark. Data Lake Analytics is our own proprietary tool that doesn't fall into any of the open source technologies. We call it uSQL. It has great integration with Visual Studio. And from Visual Studio, without a need for installing it in a cluster or something, you can run analytics on your data stored in a data lake store, and we take care of the back end of all the servers that need to be there. And machine learning, the Azure machine learning is just a workbench that can help you build models and also operationalize your model. And once you have the intelligence built, you can either visualize it using Power BI, Tableau, Qlik, or you can use our cognitive services. Those are basically APIs to build your applications, bot framework, building chatbots, or vision and text analytics API, and build your web application. So this pretty much gives you, I ran through a laundry list of the products that are available. I was just trying to give you a big picture. When to choose what, right? So you pretty much have these three are the major options when you are dealing with big data analytics. Hey, I'm very comfortable with Cloudera, MapR. I want to use their tool. Use Azure Cloud as just an IaaS VM. Install your tool of choice and run it an IaaS cluster. The most preferred way is HT Insight. HT Insight is nothing but our 100% open source Hadoop that's managed by Microsoft. So you don't worry about updates, patch management. You just tell us how many node cluster you want, boom, you're there. You just focus on running either your MapReduce job or Spark, whatever you normally do on a Hadoop cluster. The data analytics piece is the fully managed big data as a service. That's where you just go into Visual Studio and write C# and uSQL, and you can actually get insights from petabytes of data. So I know you guys have looked at enough slides, so I'm going to switch over to a demo, and instead of showing you how a HT Insight cluster, a Hadoop cluster is constructed, I think it'll be more beneficial if you just see hands-on. So for this demo, what I'm going to do is, this is Azure GovCloud. I'm going in, I'm creating a HT Insight cluster. All you need to do is I pre-filled some of the requirements. All you need to do is just tell what kind of cluster you want. If you look at the options that are out there, Hadoop, HBase, Storm, some of them are in preview if you want Kafka or Hive. Say you want to run a Spark cluster on Linux, you select the version you want to run, latest version, and you can pretty much do the quick create, specify your storage account, and you'll be there. You want to customize it more, click on the custom settings. And if you look at it in the custom settings, while you are creating the cluster, this being the GovCloud, there are right now 4 choices. I know it's hard to see for some people. You can run H2O, which is a very popular AI library. You can run their toolset, install the application, or one of our marketplace items, this is how many nodes, worker nodes, and name nodes you want to put in, and it will adjust accordingly, depending on what type. And the great thing is you can run, at the time of the cluster creation, you can run any kind of scripts you want. You want to customize your Hadoop cluster, you can run any of the scripts, like install scripts that you can do. So for this demo, what I have done is I created a cluster using CNTK. Anyone heard of what CNTK is, Cognitive Toolkit? TensorFlow? Okay, so Google's version is TensorFlow, Microsoft's version is CNTK. Both are open source, it's extensible. You can do whatever deep learning you want. So it's a very simple shell script that you call to install CNTK or TensorFlow or Theano, any of those deep learning tools. Or if you're not interested, you can even install SparkML, the basic commands. So once you have done that, when you just click next, that's it. You just create a Hadoop cluster. If you have gone through the pain of standing up a Hadoop cluster in your environment, you know this is 1,000 times easier. And there are no other configuration needed until you need to manually go in, SSH into one of the head nodes and do something. Otherwise, everything else is configured standard. I have a HD Insight cluster running. And if you click on the URL, if you're familiar with Ambari, that's the maintenance of the Hadoop cluster, you get the Ambari UI right away. Let me log in. So this is pre-configured, ready to go. You don't need to do any configuration. If you want to adjust anything on your Spark instance, I'm running a Spark cluster. So if you want to adjust any of the configuration on your Spark service or any of the services that are running, if you're just running Hive queries, you can come and change your configuration here. So how many of you are familiar with Jupyter notebooks? So Jupyter notebooks is very popular because the days where you had all the data put into a data lake or your Hadoop cluster and run a batch job and submit a report to your management, those days are gone. These days, the data scientists have access to your entire data lake, entire sets of data, and depending on the need, today it could be analysis of something that happened in this particular agency, or somebody mentioned about this person of interest in the news. You want to do a search on this particular person on all the data you have. So this is where the data scientists and data exploration people come in. So it's a Jupyter notebook and Zeppelin notebooks are an interactive query tool. Think of it as an interactive query tool where you can run R and Python or Scala in the Spark instance. You can run them. So I have a sample. Spark Python notebook. What this does, it uses CNTK, our deep learning neural net, and classifies images. Computer vision is a huge, huge industry because no matter what you look in the digital transformation, from self-driving cars, autonomous semi-trucks, to finding person of interest in the case like the Boston Marathon bomb, right? You want to sift through thousands of images, if not millions of images, and find patterns. You can apply that to any industry. We were talking about aerial images, even with FEMA, with the hurricanes that are going on, right? You can look at the aerial images, earthquakes. You can look at the aerial images where the most damages are. You can fly drone in and analyze those images real time. What do you need for that? A great computer vision algorithm where it can pick up variations and anomalies in the images in seconds, and a very fast way to do that. So I won't bore you with all the statements here. This is in GitHub. It's posted in GitHub. We'll share the link. I'll share the slides also in our meetup group. So what this does is it brings in, they run through these image classification contests. This is the big nerd contest. All the computer scientists jump in and how fast they can recognize a cat as a cat. Or a room full of people with refrigerators and a cat hiding behind a refrigerator, they can still identify the cat, right? This is where the computer vision is going. And they have standard data sets, and what these statements do is bring those data sets from a publicly accessible, this is from toronto.edu, a CIFAR data set, bring it into your data lake or blob storage in this case. Spark does everything in memory, so what they call is a resilient distributed data set, RDDs. So it loads into an RDD, and this just queries, hey, my image is there or not. It brings in a trained CNTK model into it. And you can see when I test the images for 10,000 images, it ran through and classified those images in 1 minute, 25 seconds. Writing on it. So right there, that's to score 10,000 images. And if you look at some of the patterns and the accuracy of it, it was accurate like 91%. A minute and 23 seconds for 10,000 images. And I'm running in a 4-node cluster. If you want faster performance, all you have to do is scale it up to, say, 30 nodes or something, and you can get it. And this is a fun representation I tried to do. I played with different colors. It doesn't show that good, but you can see where that 9% error occurred. Some of the cats were diagnosed as dogs, and some of the dogs were diagnosed as cats. So that was just a taste of what you can do with the Hadoop cluster, with the deep neural network. I'll share the slide just because of the time concern. I'm just going to skip it. One thing I want to mention, if you ever use a Skype translator, if you want to talk to your grandparents who don't talk English, try the Skype translator. We implemented CNTK in it, and the error rate is less than 6%, which is less than what human translator can do. And it's real-time translator. I have slides to also, I ran through a laundry of list of all the data analytics stack up in Azure. When to use what kind of a guidance is also in the slide. I'll share that in the meetup group. And you don't have to believe any word I said. Read some of the Gartner and Forrester Wave analysts reports. You'll find out that, any questions before I turn over to Bob? Thank you, and I'm available after if you want to